I'll go through this one. I'll explain this one. So, um, it is saying, yeah. So the curve C. Let me just move it a little bit. Has those parametric equations, and we want to find the points where it meets the x-axis. So remember, on the x-axis, that is where y is equal to 0.
Yeah.
So if that's where y is equal to 0, then we make y over here equal 0. So we say that 0 equals 3 sine of 2t. Which means that sine of 2t must be equal to 0.
Yeah.
Which means that 2t is equal to 0, because inverse sine.
Yeah.
Inverse sine of 0. So 2t is equal to 0, but it can also be equal to 180, but in this case, pi. And then that's just using the fact that, if you use a little sine graph, you've got 0, pi, 2 pi. We can see it's 0.
Oh, yeah, true.
Yep. Over here. And here. And here, but we don't want that value. So that means that t is equal to 0 or t is equal to pi over 2. So those are the 2 points where the curve meets the x-axis. But it says, well, yeah, it meets the x-axis when t equals 0 and t equals pi over 2. I believe that's all they wanted.
Oh, okay. Is that what we're going to have to say?
Yeah. If they really wanted us to go further with it, then we can just substitute that into x as well.
Yeah.
So x equals 5 cos 0, which is 5 times 1, because cos 0 is 1, which is equal to 5. Therefore, the xy coordinate would be 5 comma 0, because y was equal to 0. And then for the other one, we have x. For the other one, we have x equals 5 cos of pi over 2. And x is equal to 5 times 0. Because cos pi over 2 is equal to 0. Remember, this is in radians.
Yeah.
So the other coordinate is 0, 0, which makes sense because in the diagram we can see it touches the x-axis here and here. But yeah. Now next, find the area between the curve and the x-axis. This is the bit that we've been waiting for, right? This is the bit where you were like, what's going on? So that's what we're going to do now. Okay, so find the area between the curve and the x-axis. So we essentially are trying to integrate the function y with respect to x. That's typically what we do, right? That's what we're used to doing when you have it in terms of x and y. So we need to know what that actually is. Well, first of all, we can write this as this. And we can integrate that with respect to t. Looks a bit complex. Why on earth would I do that? Well, first of all, note that if we were to treat these like fractions, the dt's would cancel, and you're just left with that same expression.
Just the x, yeah. Okay.
But by writing it in this way, it allows us to integrate with respect to t.
Okay.
So what essentially we need is, first of all, we know what y is. We already know. So we know that y is equal to 3 sine of 2t. And we can work out that dx dt is equal to, well, that's just minus 5 sine t, because x was equal to 5 cos t. Cos differentiates to minus sine, so it's minus 5 sine t. Now, we've transformed this integral into the integral of y times dx dt, but y is equal to 3 sine t. That's 3 sine t. The dx dt is equal to minus sine t. And then it's just dt. Sorry, minus 5 sine t.
5, yeah.
And then that simplifies to the integral of minus 15 sine squared of t dt. To make it even nicer, I'm just going to take out the minus 15 to put it on the outside. So minus 15 times the integral of sine squared of t dt. But then that begs the question, how on earth do we integrate sine squared? Well, quite nicely, we can rewrite this using trigonometric identities. So if we note that cos of 2t is identical to cos squared t minus sine squared t using the addition or double angle formula, that's something that we need to be aware of.
Yeah.
We can then rewrite the right-hand side in terms of sine squareds. So cos of 2t is identical to, cos squared is the same thing as 1 minus sine squared t. And then it's minus the extra sine squared t. Cos of 2t is identical to 1 minus 2 sine squared t. And then to get sine squared on its own, if I add 2 sine squared t to both sides and subtract cos 2t, I get 2 sine squared t is identical to 1 minus cos 2t. Dividing both sides by 2, we get sine squared t is identical to 1/2 minus 1/2 cos 2t.
Yeah.
Make sense?
Yeah.
Okay, I'm just gonna see if I can shrink this. Okay, let's make this a bit smaller. Can you still see on your end?
Yeah.
Awesome. Okay, cool. Lovely. So now what I'm going to do is, now I know that sine squared t can be written as 1/2 minus 1/2 cos 2t. Instead of writing minus 15 sine squared dt, I can put minus 15 times the integral of 1/2 minus 1/2 cos 2t. That's easier to integrate. And then that's minus 15 multiplied by, so we've got 1/2, which integrates to 1/2 t. And the minus cos 2t, well, that integrates to minus 1/2 sine 2t divided by the differential of the inside bit, so the differential of the 2t, which is 2, like that. And then the limits of integration, because it's for an area, we worked it out in part A. That's going to be between 0 and pi over 2. So that's going to be minus 15 multiplied by, first of all, pi over 2 put in as a limit. So that's 1/2 times pi over 2 minus, first of all, this minus 1/2 divided by 2 is minus 1/4, so I'm going to simplify that to 1/4. And then we have sine 2 lots of pi over 2, putting that in the sign, that's going to become pi.
Wait, wouldn't it just simplify to 1 be 1 over 2?
What?
So you simplify that to 1/4 sine.
Yeah.
But wouldn't it be just 1 because doesn't the 2 come onto the top of the fraction?
No, you're dividing by 2. If you're dividing by half, then it would come on top of the fraction.
Then it would come, okay.
Yes. That's it. Okay, and then so it's that minus, and then we put the 0 in, so that's 1/2 times 0 minus again, a quarter sine of 0 this time. And then that's just going to be, well, minus 15. And you've got a half times pi over 2 is pi over 4. Minus a quarter times sine of pi, well, sine of pi is equal to 0. So that bit's just 0. And then...
Wouldn't that be pi over... Oh, no, because it's times 2, okay.
Yep. And then the minus a half times 0, minus a quarter times the sine 0 is all 0. So it's just minus 15 times pi over 4. I'm just checking, did I make any silly mistakes anywhere? I didn't think so. Nope. Okay, so we get minus 15 pi over 4. But the area itself is equal to 15 pi over 4 units squared.
Okay.
Make sense?
Yeah, okay.
Awesome. Oh, someone's at the door. 1 second.
That's fine.
Yeah, I'll let you try the next question. Give me a minute.
Yeah, okay.
Okay. Hello. For viewing, right?
Yes.
Lovely stuff. Come in.
Is it okay if you take a video?
Absolutely, yes.
Thank you.
Yes. Sorry, give me just 1 minute. Yeah, you can take a video. I mean, I do have a video in place, but if you want to take it, I can send it to you. But if you want to take your own video, that's
Sure.
yeah. Lovely.
Thank you.
Brilliant.
Are you
So
enjoying?
yes, I'm enjoying.
I thought we were doing more explaining.
Yeah, that happens a lot. Welcome. Did you travel from far, by the way?
From Acton currently.
Okay, right. So a bit of a distance.
A bit,
Okay.
yeah.
Do you both live in Acton?
No, Michelle is, I live in Wandsworth, yeah. Just,
Oh, you live quite close.
Yeah.
Okay. Awesome. Are you moving together or yeah? That'd be the idea. Cool.
Together, yes, together.
Awesome. Nice. Well, so yeah, we've got the bathroom.
Mm-hmm.
Let's start off here. Would you like me to send you the video still, or do you want to?
Yeah.
Yeah. Okay.
Thank you, Lori.
No worries. If you, well, I can give you my number. You can put the number. So 079 5771 9064. Lovely. If you send me a WhatsApp message or something, then I can send you. I can reply. Yeah.
Thank you.
That's okay. Yes, so we can carry on with the tours. Yeah, please feel free. You can go through. Or can I just ask that you take off your shoes before we go on to the carpet? No worries. No, it's okay. It's okay. This bit is fine. It's the rooms where there's carpet.
Yeah.